Hello everyone! In this video I would like to guide you through the thinking process behind the solution of FizzBuzz puzzle. The instructions of puzzle are the following. You need to print numbers from 1 to 100 inclusive, following the rules as such. If the number is divisible by 3, you need to print fizz. If number is divisible by 5, you need to print buzz. And if number is divisible by both 3 and 5, you need to print FizzBuzz. Otherwise, the number should be printed. Not waste your time, I already created the tests for this puzzle. So as you see, for numbers 1, 2, 4, 7, 8, 11, 13, we will be just printing their stringified version. For numbers 3, 6, 9, 12, 24, we expect fizz to be printed. And for numbers 5, 10, 20, 25, 35, 40, we expect buzz to be printed. And for numbers which are both divisible by 3 and 5, which are 15, 30, 45, and so on, we expect FizzBuzz string to appear on our screens. Let's start. I would like to approach this puzzle by having the execute method, where I will be just doing the iteration. So as we need to start from 1, that's from where the loop will go. It needs to be up to 100 and incremented by 1. And inside of this loop, we want to get the result of transformation of the number into the string. So basically to apply the instructions from above. For this, I will use the separate method to keep everything clean and neat. And we just print the log inside of this loop. So we transform number to the string and we print it out. Let's check. How the application behaves. Now, only empty strings should appear in tests, as that's how we map any number, and we start from that point. This is basically the idea of test-driven development, that you create tests before, and then you see there are nothing. There is nothing, no logs in the output. So if we want to approach this solution in a straightforward way, we will just create 2 if statements, or even like 3 if statements basically, and else statement to follow the rules. So intuitively it will be something like that. If number modulo by 3 equals 0, we return fizz. If number modulo 5 equals 0, we return buzz. Otherwise, we return stringified version of the number. Let's check what it gives us. By the way, neater way to create the tests will be to follow to create different test method for each of the instructions, but we can leave it for later. Now let's see where the test failed. It says it failed on the line 45, which is the first occurrence of the number divisible by both 3 and 5 numbers, which is fair enough, as we don't have this rule here. In order to introduce it, we can either go in this direction, which is pretty bad, it will work, of course, but it's the worst way to solve this puzzle. So as you see now, tests are green, meaning that all of the assertions were asserted successfully, but such constructions as nested ifs, it is the worst paradigm of software development, of making any kind of scripts, as it's just bad. It's not extendable. If you need to add the rule that number is divisible by 7, you will need to nest another if. It's just not good. It's not working at all. A bit better solution will be to create the variable. In Java, we have a specific type of variable which is called string builder. What it does is that here in this line 26 it is empty, and you can just start appending strings to it, and basically if it enters here, it will not be empty anymore. It will contain fizz string inside. If it will enter here, it will contain also buzz string inside. And if it enters both places, it will contain both fizz and buzz inside, which is what we wanted. And in return statement, what we need to do is to check if this result is empty. If it is, we want to return the stringified number, and if it's not, we want to return this string builder to string. This is a bit better approach, as it's cleaner and it's much more easy to add any other rules. For example, if you want for number 7 to add any other sequence of the characters, you simply add another if statement, and it will be working from the very beginning. But it's also not the best way to do it, as imagine that you need to add that you have not 2 or 3 rules here, but you have 10, 20, 1000. Then writing for each rule the nested if statement is still not going to do well for this code. So another approach is to think about the separation of the responsibilities. Because here what we want to do in this method is we give him a number, we give the number to this method, and this method returns us the stringified version of this number. This is the only responsibility which we want to dedicate to this method. And the responsibility of understanding how these numbers need to be mapped to the string, we can dedicate to the other entity. So let's create the record with, well, we can name it a rule, basically, or instruction. I think rule suits here better. The rule here is simple. If it's divisible by some number, we need to print some string. So the rule is number and string. Actually, we can name the fields of this rule a bit better. So number is something that we want to get the string from. So from, and string is something that we want to transform the number to. Meaning that now we can create 2 rules. For this, we'll use the list. And we will put both of the rules inside. So from number 3, we want fizz line, and from number 5, we want buzz. Now as we have these rules expressed in a tidy way, in a clean way, we can immediately apply them instead of this is nested if. So we basically need just to iterate through each of these rules and follow the logic that if the number is applicable to the number of the rule, so basically let me just revert a piece of code so I can show it. Maybe I can express it, I can explain it a bit better. These 2 lines should be enough. So look, now this rule, it contains the number and the string. Well, maybe from is not the correct name actually, as it's divisor. Divisor, I think divisor is more correct name for this place, for this rule. It doesn't matter, but it's just for the better naming. This naming is also important, not for the machine, but for us human beings. So if the number, so same number as we have in this if, it's absolutely the same, as it's the same variable. But here now, instead of checking modulo 3 or modulo 5, we just check modulo of the divisor, which we take from the rule. And then here, instead of appending fizz or buzz or any other sequence of characters, we just apply the string from the rule, which will be fizz for the rule 5 and for the rule 3, sorry, and 5 for the rule, and the buzz for the rule 5. These two now can go. We run the tests. And this works. There are a few more things which we can implement, but if I was to choose only one, it will be to move this check inside the rule itself. So to check if the rule applies to the number, we need to do the following. Basically, it's the instruction. If divisible by. If, because it's Boolean, divisible by. Same thing. And now instead of having this logic here, we just check that rule applies to the number. And it works. Yeah, it works. And one more thing, which also helps to keep the logic more clean, is to separate the filtering and the applying of the logic. For this, we can use the Stream API, which Java kindly provides us. Filter each rule, basically filter out only those rules which are interesting for the current number, and then we don't need this check inside the for each loop, as we moved it to the filtering step of the stream. And now with such setup, I'm pretty content with what we were able to achieve regarding the solution of the FizzBuzz puzzle. It's pretty interesting puzzle, not too complex, but still has its charm, I would say. Actually, I was introduced to it on my first successful job interview for the sub-hybris company, and I did not solve it in such way, of course. And my solution was much worse at that time, but now, almost 11 years later, I can really see the beauty of this puzzle and what it can show to the interviewers. Nevertheless, thank you very much for being for following this solution with me. Hope this video was useful for you, and hope you have a great day.